I think about
Yeah.
those things all the time. How do we mathematize stuff that we just kind of see in our space and think about? And some things it don't. Sometimes it don't have a context. One activity that we did is we were out in the field. The boys were out playing soccer, throwing the football around. And I just asked, because I saw this activity in one of the NCTM journals, and it just dawned on me to ask, how many blades of grass out here? And you would I, some of my boys started sitting down and started counting them. But like, dude, you're gonna be here all day counting all this blades of grass. What can we do? And so they came up with different strategies. Some of them said, well, we can do, they're like, well, because it was on a field that was marked off. And so they began to mark off these huge rectangular proportions that were somewhere in the neighborhood of probably 2 or 3 yards by 2 or 3 yards. Like, you're still gonna be here all day counting plays. And ultimately, what happened as they began to partition this thing down, they partitioned it down to 1 inch by 1 inch, and then they figure out how many blades of grass are in 1 inch by 1 inch square. And then they extrapolated that up to fill up the entire field. But it took them literally 2 days of mathematics to do that, to figure it out. I didn't ask, I didn't, I literally just asked the initial questions and just asked other questions. And they were dead set on figuring out number of blades of grass. But then it came up, well, this part don't have any grass in it because it's dead. I'm like, okay, so how are we going to get, if we counted with all the blades of grass in this here, how can we then take out the dead spots? So now they're walking around looking at dead spots to kind of get rid of it. And so, it was a fun activity. It was one of those things where they were bought in. And so sometimes it's contextual. Sometimes it is one of those things where where they ask questions about mathematics that they need to know in order to solve the problem they need to solve. And I love finding activities or creating or thinking about activities. And and for this activity, I had one of my students from UVA with me who was kind of co-teaching with me. And she would ask me, well, what's the answer? I was like, I don't know. I literally don't know. We'll figure this one out together. And the thing I hope to model for her is that sometimes, it is the engaging task, and that helps us think about what they learn. They learn proportional reasoning, they learn how to, and if it's constant, we can then take this, okay, if it's 500 blades of grass in this 1 inch by 1 inch, and it's pretty constant, we can begin to kind of actually it's a linear, so it becomes a linear equation, all of the math that they can learn there. So I was like, I'm really focused on this. I don't know what the numbers are, but I know what the content will be that I can extrapolate from that to do the representations that we need to do. So I want to model for my student that the vulnerability sometimes that we have to have. And sometimes we can be vulnerable enough that, and I let the boys know, I was like, I don't really know how many blades of grass out here. And once we got an answer, and we had several different answers, but they were reasonably close. And the question is, will we really honestly ever know? And they all were like, no, we probably won't ever know, but we are so close that we can agree on things. I was like, yeah, I was like, you know what? And sometimes math is made up that way, right? Sometimes we don't know the answers to some of the most important problems in our lives, but we know that we're so close that we just say, you know what? Let's all agree that it's this. So, some of these important questions that come up that people, and they're just shared agreements. And so sometimes it's that. And sometimes we have to be exact too. So, I don't want to give them the impression of that as well. I know.